Good morning to all. Myself, Dr. Arun Nigam here. Today, I'm going to take one topic from fluid mechanics for aerospace subject, and the topic name is boundary layer thickness. So, what is meant by boundary layer? These are all the things uh, we have discussed in that last session. So, boundary layer means the boundary layer. It will be formed above the flat plate or some other solid regions. That boundary layer, we will get the two types of boundary layer. One is for a laminar boundary layer, another one is for turbulent boundary layer. And now we are going to discuss about the boundary layer thickness. So boundary layer thickness means the distance from solid surface to the point where the fluid velocity reaches the certain percentage of free stream velocity. That is called as a boundary layer thickness. So the most common definition is distance from the wall where the local velocity is 99% of the stream value. That is called as the boundary layer thickness. So in that boundary layer thickness, it can be classified into three types. And boundary layer thickness, it can be classified into three types. And the first one is the displacement thickness. So in that displacement thickness, so in that displacement thickness, it can be denoted as delta and delta star. So here where the delta, it is nothing but displacement and distance travel from one region to other region, that is called as the delta. So in that normal distance to reference plane representing the lower edge of the hypothetical fluid of the velocity, that is called as the UE in this region. So if the delta star, it will be it is denoted as a displacement thickness, that is called as delta. Delta means displacement, delta star means displacement thickness. So if the formula of the displacement thickness is integral of 0 to del 1 minus small u by capital U into dy. So here the u, it is nothing but the free stream velocity, and capital U, it is nothing but a asymptotic velocities. So in that displacement thickness, it is not directly related to the boundary layer thickness. So, but if the values, approximate values is given by delta by 3, it will be related to the delta by 3 values. And next one is the definition of the displacement thickness. The distance perpendicular to the boundary by its free stream is displaced due to the formation of boundary. That is called as a displacement thickness. That is called as delta star. Next one is the momentum thickness. So momentum thickness means it is defined as the distance measured perpendicular to the boundary of the solid body by which the boundary should be displaced to the compensate the reduction in momentum of the following fluid according to the boundary layer. So in that momentum thickness, it has to be denoted as theta. So this momentum thickness is not directly related to the boundary layer thickness, but it gives approximately values by delta by 6. It has it is a major role in the calculating the shape factor. The related parameter called the energy thickness is sometimes mentioned in the reference to the turbulent distribution, but rarely used. And last one is the energy thickness. So in that energy thickness, if the denoted is delta double star, it has been defined as the distance measured the perpendicular to the boundary of the solid, which is the boundary should be displaced to compensate from the reduction in kinetic energy. Kinetic energy means rho AV, sorry, of ma squared. It is called as kinetic energy. Potential energy is rho AV. So in that energy thickness, it can be denoted as delta double star. So if the formula is 0 to del capital small u minus capital U into 1 minus u squared by small u squared by capital v u squared into dy. So here u is nothing but the free stream velocity, and small u and capital U is nothing but the absolute velocity, and delta it is nothing but a deflection of free stream velocity. So okay, thank you. So next we will catch you on next topic in upcoming lecture series.